Hello and good morning, ladies and gentlemen. I'd like to wish you all a very warm welcome to the latest edition of the Irish Bioenergy webinar series. So my own name is Stephen McCormack. I'm a project executive with Erbia, and I'll be chairing this morning's session. Now this is a role that normally is handled by my colleague and Erbia's CEO, Sean Finan. This morning, we are delighted to be joined by Daniel Hayes from Celignis Analytical for a webinar titled The Role of Analytics in Maximising Bioenergy Feedstock Potential. But before we begin and before I introduce our speaker, I'll start by giving you just a brief introduction to Erbia, so who we are and what we do. So we were founded in 1999 and established to be the representative body for the bioenergy industry here on the island of Ireland. And we cover the areas of biogas, biomass, biofuels, wood fuels and energy crops, as well as the emerging biochar sector. Now, as a membership organisation, we are involved in the areas of policy, lobbying and advocacy and knowledge transfer on behalf of our members and the different bioenergy sectors. Our membership covers a broad and diverse range of different individuals, SMEs and organisations. So everything from individual farmers and foresters to technology providers, semi-states, fuel suppliers, academia, and as we will hear from soon, analytical companies. We're also involved in a number of different project activities, including the administration of the Wood Fuel Quality Assurance Scheme, a European Innovation Partnership looking at small on-farm biogas demonstration, an Interreg Northwest Europe funded 3C project, which is focused on the creation of a circular carbon economy through the use of biochar. And then finally, a Just Transition funded project called the Midlands Bioenergy Development Programme, which will see us provide technical support to potential bioenergy-based startups and SMEs within the Midlands region. Now, we are, of course, always open to new members, and should you wish to find out more about any of the work that we do, you can visit us at erbia.org. Now, just to draw your attention, this is the 28th webinar in our series, and to date we've covered an interesting array of different bioenergy related topics. Now, they're all freely available for you to watch back, and you'll find them linked from both our webpage and listed on our YouTube channel. Now, we host them fortnightly on a Wednesday morning between 9:30 and 10:30. And if any of our attendees, stakeholders or members wish to get in touch to discuss future topics or wish to highlight any particular projects or work that they might be involved in, we would be more than happy to hear from you and to facilitate where possible. You can do so by contacting myself, Sean or Teresa at the addresses provided or through our website. Now, so just a very brief look at the agenda for today's webinar. So we're looking forward to hearing the presentation from Dan from Celignis, which will probably run for about 20 to 25 minutes. And then we will make time for questions and answers and a discussion session where we'll hopefully be joined by my colleague and Erbia technical executive, Noel Gavigan. And so I would encourage you to get involved and submit any queries, observations or questions to the Q&A tab, which should be located at the bottom of your screen. And we will endeavour to answer as many of these questions as possible. And then I'd like to briefly draw your attention by ways of a save the date for our next webinar, number 29, scheduled to take place in a fortnight at the usual time at 9:30, and full details will be announced in the coming days to our usual channels, social media and mailing lists. And now that the housekeeping is out of the way, I would like to introduce today's speaker, so Daniel Hayes. Dan is the CEO of Celignis Analytical. So it's a company specializing in analyzing biomass feedstocks for the provision of bioenergies and to serve the emerging bioeconomy space. Dan received his PhD from the University of Limerick and over the years has been involved in a number of research projects and consortiums, which has led to the creation of the company capable of filling the biomass analysis needs for customers both home and abroad. Now, with a focus on being able to provide quality data using cutting edge processes, equipment and techniques, Dan and the growing team at Celignis are well placed to cater for all your biomass analysis needs. And with that brief introduction, I'll now ask Dan to switch on his camera and begin his presentation. So over to you, Dan.
Great. Thanks very much, Stephen, for that introduction. And thank you to the team at Erbia for giving me the opportunity to talk a little bit about the work that we're doing here at Celignis related to the characterization of biomass and also the development of biomass processing technologies to really effectively valorize these feedstocks. And the title of the presentation is The Role of Analytics in Maximizing biomass feedstock potential. And it's very important to firstly ask the question, what do we mean by biomass? So it can be considered to be any kind of biological material, organic derived material, and this can include a wide variety of different feedstocks with massively varying compositions and suitabilities for processing. We just see some examples here in the pictures on the right-hand side. The different types of feedstocks, they can be classified into a number of different groups. You can have energy crops. In the Irish context, then such crops of relevance would be, they would include miscanthus, they would include some of the coppices, such as willows and poplars. You can also potentially take agricultural residues as feedstocks for valorization. Biomass materials, you can have straws, you can have highly wet agricultural residues such as animal manures. Moving forward then onto potentially lower value feedstocks, which are more abundant. You can have various types of municipal waste ranging from source segregated waste, for example, to a heterogeneous black bin type of material. And of course, then you have the residues from various types of industries that are processing biomass and biomass derived materials. And they can have a number of different side streams, which can have, again, wildly varying compositions. And again, their suitability for processing will depend on their composition and the type of technology that you're looking at for valorizing these. And again, as well as the biomass, then you have the question about the technology, and there are a number of different processes that you can potentially use for valorizing biomass feedstocks. We can roughly group these again into various types of processes. So for example, you can have thermal conversion technologies, where you are basically looking to break down the majority of the biomass for energy production purposes. So technologies can include the relatively more simple processes such as combustion, moving on towards gasification, and pyrolysis. And in the instance of pyrolysis, for example, you can have a various number of technologies. You can focus, for example, on the production of a bio-oil product, where you would use a process called fast pyrolysis, or you can focus on the production of biochar, where you would take pyrolysis over the course of a much longer period of time, maybe 30 minutes or so, and you're looking to produce the majority of a solid residue product rather than a bioenergy products directly. Other types of processes include biological conversion of biomass, and this can include existing technologies that we have in Ireland, such as anaerobic digestion, where we're looking at the effective breakdown of this organic material by a biological process to produce biogas, principally a biomethane component within the biogas that can then be burnt to produce energy. Alternatively, then other types of biological processes focus more on the selective degradation and destruction of the biomass matrix into its constituent units. So an example for that would be to use enzymes to break apart the structural polysaccharides of biomass, such as cellulose and hemicellulose. And when you get those then to their individual sugar monomer units, they can be valorized by various numbers of processes, for example, fermentation to produce a product such as ethanol. And there's other types of products as well that you can produce potentially of higher value going forward for application in sectors other than energies, for, let's say, production of bio-based chemicals, bio-based products, and so forth. Alternatively, again, you can look at non-biological routes for decomposing, degrading, deconstructing, and valorizing these biomass feedstocks. These can involve chemicals, it can involve the use of acids, the use of solvents to selectively degrade and fractionate various types of biomass feedstocks. And as I mentioned, which one of these is suitable will really depend on the feedstock that you're looking at a particular time. In particular, for example, in a very simple context, moisture content varies massively according to the different types of feedstocks you're looking at. It can be very low in certain types of agricultural residues, such as straws, for example, but it can be much higher when you're talking about other types of agricultural side streams, such as animal slurries, where you can have nearly 95+% of the feedstock being water. And this will restrict, in some cases, what technologies are suitable. So it really is a fine balance between all of these different things. You can have a great process, but if you put the wrong feedstock in it, it's not going to work, and you're going to end up with that sad face then. You can have a great feedstock, but you also have to consider, of course, the cost that is involved in either buying that feedstock or getting it supplied to you from wherever it is being produced, or getting it into a form in which it can be effectively processed by the technology that you're looking at. So the price is obviously an important consideration. Again, we're looking at biomass. So really it's balancing all these three things together. It's looking at the composition, that it's suitable for the process, getting a price that makes the whole thing commercially viable, and then also matching up with the technology that can efficiently valorize this feedstock to give you the desired products and the desired income that is sustainable over the years. So I'll just give a little bit of background to why Celignis was formed. I originally went to UL, as Stephen mentioned. I was doing a postgraduate study there. It was only meant to last 1 year. It took a bit longer than that in the end. It was originally focused purely as a desk-based study, a master's that would look at the potential for producing advanced biofuels. And by advanced biofuels, we mean particular focus on breaking down the lignocellulose constituents of biomass into the sugar units, and then using those sugars to produce biofuel products such as ethanol. It's a new type of technology, and it requires a new set of data than what has previously been looked at when you historically evaluate biomass for processing in various types of valorization technologies. So previously you would focus on moisture content, calorific value, ash, and other things like this. For this type of analysis, you need to look at the chemical composition of the feedstocks, and it requires an extensive amount of work. And I found that really the data was severely lacking, particularly for the Irish context. It was okay to find about the availability of the feedstocks, but to actually know under Irish conditions how this composition changes, there really wasn't any data out there. So I decided really to develop that capability within Ireland to really effectively analyze these feedstocks and see their potential for the country to be self-sustainable in production of biofuels and potentially going forward in bio-based chemicals and other biomass-derived products. So within my time at the University of Limerick, I obtained some funding, which was generously provided by national institutions such as the Department of Agriculture and the EPA to build the capacity within the university for this biomass analysis. I transferred to doing a PhD focused on really producing this database for the Irish context of what feedstocks are suitable under various conditions for various types of biomass processes. And within that PhD also, I looked at the development of rapid analysis techniques to reduce the time to determine this lignocellulose composition from the standard approaches where it takes in the order of 2 weeks to using spectroscopic approaches, using the infrared spectroscopy where it can be done in a matter of seconds potentially. During the time at the University of Limerick, we were fortunate. I wrote a proposal for funding by the EU's 7th Framework Programme. This was successful, and UL coordinated a collaborative research project focused on production of advanced biofuels, working with institutions in Europe and Latin America. The focus of the technology was on an acid hydrolysis process, but there was also a significant part of the project looking at the potential of the feedstocks both in Europe and Latin America, looking at developing advanced analytical techniques to evaluate these feedstocks, again with a particular focus on this near-infrared technology that I was working on during my PhD. As part of that project, we wrote a deliverable focused on a potential company that could be set up to exploit this IP developed in rapid analysis, as well as the various techniques for compositional analysis that we developed in the project. And after writing that business plan, I decided that there was really sufficient potential there to actually have a go at it for real. And back in 2014, I decided to set up Celignis. Here we have some of the history of the company in the last couple of years. So we started out small. We were basically in the lab in which I was doing my PhD at university. Very soon, though, I was fortunate to move to a dedicated laboratory for the company, which was housed in an enterprise incubation centre within the University of Limerick. In 2016, we secured our first collaborative European research project called Biorescue. That was very important, but that allowed us to prove our capabilities as an independent company to do pioneering scientific research and to prove our pedigree in this European context. And it's allowed us over the coming years to be involved in an increasing number of such projects going forward. That's an interesting project, actually, that first one we did. It was called Biorescue, and it was very much an Irish-focused project. We were looking at spent mushroom compost, which is the residue compost after you produce the mushrooms from it. And it's a particularly problematic feedstock. There is no current use for it. It's a problematic resource that's generated in Ireland in significant quantities. And within that project, we looked at the composition, we looked at the variability in composition, we looked at technologies in which potentially that composition could be valorized for producing bio-based products. In 2018, we moved to our own dedicated building, also within Limerick, down the road from the university, but on an independent technology campus. At the time, I thought it was too big for what we're doing. It very quickly became very much too small because every square inch that was available, we used it to populate with all kinds of exciting analytical and biomass processing equipment that we have used to expand significantly the services that we offer in this space. For example, then in the subsequent year, 2019, we expanded beyond purely doing analysis services to also looking at development of bioprocesses for clients. And I'll expand on that shortly in a later slide. And as I mentioned, in the coming years from then, we've been very fortunate to be involved in a number of very exciting EU projects, which has allowed us to expand our capabilities and our personnel and our standing globally in terms of biomass research. And again, as we've expanded these personnel and our capabilities, we've done a number of different things over the years. So we've moved forward into looking at biochars, looking at seaweed, doing techno-economic analysis, process development studies, and so forth. And I'm excited to say that this year, hopefully within the next month, we'll be moving into an additional location alongside the one we have right now. And that will be purely focused on bioprocess activities, so scaling up various types of reactor systems and biomass valorization techniques from the lab scale to ultimately the pilot scale. So I'll briefly cover the different types of analyses that we do and their relevance, particularly in the Irish context. So firstly, we have what I previously referred to, which is looking at the lignocellulose composition of biomass, where we focus historically, it has been on the production of these advanced second generation biofuels. But going forward, there's a lot more interest in producing higher value products from these sugars or other constituents of the biomass, because this allows you to have a more economically viable process than one where you're producing products such as ethanol, for example, where you're competing with relatively cheaply available fossil fuels. So in this context, what we're looking at is the chemistry of the feedstock, and these lignocellulose feedstocks, they principally have three components. They have cellulose, hemicellulose, and lignin, as well as other things such as extractives and ash, which can be important in terms of mass balance and process evaluation. This is a complex analysis. It requires a lot of highly trained analysts, a lot of dedicated work, a lot of understanding about biomass chemistry. And we're really the only company that is doing this at scale and efficiently in the world. And we've done this now in the order of 10,000 samples we've evaluated. We've got a very good understanding about how important this composition is and how it affects the type of technology that's suitable and what you can do basically with the feedstock that you have. So in the Irish context, of course, there's a lot of grass out there. There's a potential lignocellulosic feedstock. We have the energy crops that I mentioned previously, and there are also significant resources of forestry and agricultural residues nationally. Related to this is looking at the liquids that we get from the conversion of these lignocellulosic materials. So typically a technology will focus on breaking apart, as I mentioned, these structural polysaccharides. You typically get a liquid and a solid phase. And we have developed a very detailed methodology for understanding the composition at each stage of the process and inferring from that how well a process is operating, how it can be improved, and how we can effectively valorize the biomass to the best degree we can. So, for example, in the case of the liquids, they could be targeting sugars, for example, but these sugars can be present in various forms. They can be the monomer units like glucose. They can be in oligomers of various chain lengths. Potentially, you can have degradation products of these sugars, which can potentially interfere with some of the downstream valorization processes, such as fermentation. And there can be other elements that are in this liquid phase that may interfere with the downstream processing as well. So within Celignis, we can give a detailed profile of these liquid streams and solid streams, and we can also then develop processes to test them for their suitability for various downstream processes. So we can do fermentation trials and a whole number of other different things that I'll move on to shortly. Biomass combustion or thermal conversion is, of course, very important for biomass feedstocks. We have a full suite of analysis methods suitable for such characterization. You can see some of the equipment on the right-hand side there. The analyses range from the relatively simple types of work, such as looking at the moisture content, the ash content, and so forth, to looking at the calorific value, of course, which is very important. A particularly important thing is chlorine content. So you can have boiler manufacturers, you can have power plant operators. They have very strict thresholds related to the chlorine content of your feedstock, and this can oftentimes restrict the type of feedstocks that can be suitable. So, for example, if you have a woody material, typically you're going to be safe. If you're dealing with straws, if you're dealing with grasses and other types of herbaceous feedstocks, and particularly with wastes and residues, you may be over that threshold. It may limit your potential for thermally processing these materials. Related to this, we do a test that's very important, looking at the ash melting behavior of the biomass. So you can see in the bottom right-hand image there, this is the equipment we use. And to the left of that, you can see images of what happens to the ash at increasing temperatures when it's heated up within that equipment. And we increase slowly the temperature. We have a camera recording what happens to the ash over time. And we record in particular when we see this flow event happening. So that's when really the whole ash slags, it collapses the structure. And this is of particular importance to evaluating whether a particular feedstock is suitable for a particular boiler, particular biomass processing technology, because if you do get this slagging that occurs at the temperatures at which your boiler operates, it can really reduce its efficiency. It can cause all kinds of mechanical and processing issues, and you may not really have a suitable feedstock going forward. Related to that, we do a detailed compositional analysis of the ash, and particularly the alkaline metals that are present there, which influence on that ash melting behavior. And we do that via ICP analysis, shown in the top left image. Anaerobic digestion is a process for biomass valorization that's of increasing importance globally, and thankfully over the last few years nationally as well in Ireland. There have been a number of biomass plants that have been built, and going forward plans for further facilities to be constructed. And we have a very good expertise within the company now related to evaluating biomass feedstocks and also developing strategies in which these can be most efficiently valorized. So in terms of testing, we look at the biogas production, we look at the biomethane potential using this lab scale apparatus shown in the image on the right-hand side. We give very detailed reports containing all kinds of compositional data related to the feedstock. And of particular importance, we provide a written interpretation of these results provided by our AD expert, Lalita. And she really goes into the implications of the data and what it means going forward in terms of the suitability, for example, of this feedstock for AD. And we're always available, and we're always excited and happy to talk with any client or any person that has a question based on the data, or just is curious about whether they have a feedstock that is suitable. We can guide them through the whole process of how it can potentially be done, the different stages of testing and evaluation in order to really look at that feedstock's potential. And we also do this going forward related to biogas plants themselves. So we're providing biological advisory services to look at how the efficiency of these plants can be improved in terms of their biogas production, the biomethane content, and their general efficiency. Other types of analysis that we do, we look at seaweeds. There's a lot of seaweed out there in Ireland, particularly brown seaweed. We do various types of analyses related to the composition of that seaweed. It's very different from lignocellulose. You have no lignin, for example, you have a lot less cellulose. There are other types of structural polysaccharides there, such as alginate, fucoidin, and so forth. We give detailed composition of the carbohydrate profile of these seaweeds. We look at the amino acids because there's a lot of interest in the nutritional value of seaweed for either animal or human consumption. And we can also look at higher value constituents such as pigments and bioactives that are present in these resources. Biochar is something I mentioned earlier. It's of increasing interest again, nationally and globally. We have a variety of different analysis packages where we evaluate the suitability of biochar. So we can look, for example, its physical properties, such as its surface area and its pore size distribution. We can look at its suitability for soil amendment for plant growth production. So we can do lab scale pot trials related to seeing how various loadings of biochar can enhance the germination and subsequent growth of plants. And we can look as well at the thermal properties of these chars. If potentially they're looking to see if you produce a superior fuel via the pyrolysis process. Another thing we started doing recently that's of particular interest is what we call biomass detective work. So you have the major constituents of a lot of biomass that I previously mentioned, so focusing on lignocellulose, for example. But then there are other components that are present, maybe in smaller amounts, but they can be potentially of extremely high value. And we have a lot of advanced analytical equipment within the lab, which allows us to really profile these feedstocks. Typically what we do is we do a solvent extraction to remove, targeted on the removal of these non-structural components, particularly the extracted components of the biomass. And we use a QTOF LCMS system to identify what's there and to potentially see what could be of value going forward. And within that, then we not only identify these chemicals, but we can look at developing processes for their efficient extraction and their isolation. And that has been demonstrated by us in a number of EU projects, one of which is Unravel. Another one which started recently is focused on the thermal processing of African residue materials. That process produces a condensate fraction containing the extractives and the hemicellulose, and we are undertaking this detective work to look at what's in there, what's of value, how can we get it out, and how can that improve the economics of the whole process. An obvious example of this in recent times would be the valorization of hemp for the cannabinoids that are present. So particularly in America over recent years, there's been a huge growth in the production of hemp focused on extracting and isolating a cannabinoid such as CBD. What happened then is a lot of people made a lot of money early on. However, a lot of people then rushed into the sector, the market got flooded and the price dropped. But then the clever ones were the ones who then identified the next product down the line. So they're looking at CBG, for example, as a high value constituent that could also be obtained. So as long as you're ahead of the game, as long as you're looking at what's in there, you're identifying it, and you're working on an innovative process to be the first in extracting and isolating it, you can really make a lot of revenue potential from your feedstock using this approach. We also do work related to enzymatic hydrolysis and fermentation. This is what I mentioned previously. We're able to use enzymes to break apart the biomass. We can do this at various scales, ranging from flasks, lab scales, to 100-liter bioreactors. And with our new facility that we're moving into in the coming month, we'll be able to further scale up this capability to a pilot scale. We can do the hydrolysis, as I mentioned. We can also do the fermentation test on these hydrolysates to see their suitability for producing chemicals such as ethanol and other products. Biomass process development services is something that I referred to previously. What we've learned over time, the expertise that we developed in the company related to biomass chemistry and our understanding of biomass conversion processes really allows us to have a very detailed and comprehensive understanding of what makes a process work, particularly within the context of the feedstock that you're looking at. We are happy to share and to offer this expertise to technology providers or people that are looking to valorize a feedstock. So we do this by the development or the improvement of bioprocesses. And this service can range from developing an entirely new process to looking at existing processes out there and seeing how it can be improved in terms of its efficiency, in terms of productivity, in terms of cost effectiveness, and all types of different metrics that we can look at. Just some examples of the work we've done to date related to these biomass process development services. We have developed an end-to-end process for producing ethanol from palm residues from the Middle East. We've done this biomass detective work looking at around 30 different tropical hardwoods from Asia to see high-value constituents that can be present within these. We have developed technologies using enzymes and various types of pre-treatment to produce oligosaccharides or short-chain disaccharides and trisaccharides from starch and from hemicellulose, with applications in the medical sector and also in the nutritional sector as alternatives to traditional sweeteners. We're looking currently at the extraction and purification of pectin from agricultural residues, and we've done a lot of work as well related to how we can optimize the mixtures of different feedstocks for an anaerobic digestion plant in order to maximize productivity in terms of whatever metric that we're focused on, whether it's profitability, whether it's biogas production, whether it's biogas composition. We can look at a design of experiments to really get to that desired endpoint. Related to that, we're doing work on process modeling, as you can see here, as well as the techno-economic and life cycle analysis of various types of technologies for processing and valorizing biomass. So I'll just mention briefly examples that we have done to date. We have looked at the potential to process waste streams, industry waste streams, and Irish agricultural feedstocks to supply a company's energy needs via the anaerobic digestion of these resources. We've done this within the context of the current bioenergy regulations, such as the RED II directive. We've looked at the techno-economic analysis of producing oligomers from agricultural residues, producing ethanol from the gas, and in detail, we've looked at the production of seaweed polysaccharides at various scales from brown seaweed. Briefly, I'll mention, my original PhD was on the rapid analysis of biomass, which is developing these near-infrared algorithms whereby we take the spectrum of a sample and we link it to previously obtained spectral and compositional data, and we develop a relationship which allows us going forward to predict the composition of samples purely based on their NIR spectra, and that allows us to reduce the analysis time to a couple of seconds from potentially 2 weeks. And we've developed this within a number of EU projects referred to here. This year we'll be demonstrating it within a demo scale biorefinery that's being operated within Wales. And going forward, we see this as a very interesting application for technology for rapid analysis of the inputs and outputs of a process in order to effectively keep a track on how well day-to-day operations are working for that facility. Briefly, we're involved, as I mentioned, in a number of ongoing research projects funded by the EU. Noted examples would be Enzyloscope and Perfecoat. Enzyloscope, which we wrote ourselves, and focus is on the valorization of the hemicellulose fraction, particularly the xylem fraction of biomass, which has hitherto really been neglected, and we see it as a hugely important polysaccharide for producing a variety of polymer-derived products for personal care and for other consumer product applications. We're involved in a number of projects related to Africa. So Bio for Africa, we're evaluating African feedstocks and the suitability of various European technologies for demonstration in Africa. Steam Bioafrica I referred to previously. There is a torrefaction process for producing energy and bio-based products using what has been a problematic resource, a weed really, that's been growing in various parts of Africa. And STEAM is an internal project funded by the IRC in Ireland, and we're focused on developing a AD process suitable for Irish conditions and Irish feedstocks in order to really get the best yields that we can from Irish biomass materials. So just moving onwards then. So here are some of our clients that we have within the company. So really, if it's a major player in the biorefining, second generation biofuels, the bio-based chemical space, we have worked with them so far. As well, we've worked with various types of startup companies, SMEs, universities. They all recognize the expertise that we have in providing data that can then improve their process or improve their understanding of the feedstocks that they currently have. They particularly like our database that we have, so all of the data we put online as soon as we obtain it in the laboratory. You can log on, you can see it, so you don't have to wait for everything to be completed to get a final report. You will see the results of the analysis as generated, so you see some examples here. We're particularly proud of the work we've done in this context related to the anaerobic digestion of biomass. We'll provide very detailed, comprehensive reports that you can see here. You can log on and you can see the biogas production curve. As we generate the biogas each day, you'll see this curve being added to over time. So you don't have to wait till day 28 to see how well the feedstock is being digested under our conditions. And we have nothing to hide. We're very proud of, not just the accuracy, but the precision of the work that we do. We host this dynamically updated data on our website, which shows how accurate we are doing and how precise our analyses are in a range of different parameters. So finally here, we are nothing without our team. We have really built over the years an amazing number of employees with highly complementary skills. I will mention a few of these here. Lalita, who a lot of you may know from your interactions with her nationally, has been instrumental in the growth of the company over the last few years. She has a very wide and deep expertise in the valorization, the understanding of biomass, the understanding of biomass conversion, particularly along the biological route. She was the winner last year of the Irish Laboratory Awards Staff Member of the Year, and the innovations that she brought to the company also led us to win an award for the Innovation of the Year from that program. So that innovation was related to the work that we're doing in bioprocess development services within the company. Other employees of note, we have Sajna, who recently joined us. She's extremely adept in the development of new analysis protocols for understanding the sort of more esoteric chemicals that can be present in biomass. She is our biomass detective that I referred to earlier in the image. Oscar joined us about 2 years ago. He has a particular focus on techno-economic analysis, life cycle analysis, process development. And his work is particularly key in keeping us grounded and keeping our clients grounded and cognizant of the need to continually put the work that is done in context of, is it economically viable? So this is a continual process of looking at the economic sustainability of the process, evaluating it, see how it can be improved, and using that going forward in conjunction with the bioprocess development, technology development. So everything is intercorrelated in that context. And then we also have Kamal, who recently joined us. He has extremely impressive expertise related to larger scale processing of biomass. So we're talking about 650 cubic meters fermenters that we previously worked on. So within the company, he'll be instrumental going forward in the work that we're doing on scale up, the work we're doing in bioprocess development services, and the projects that we're involved in producing these new exciting polymers and polymer derivatives from biomass feedstocks. So there's some additional reading if you're interested. So there's a database you can download with Irish feedstock compositions. There's a website of the enabling project that we're involved with. You can see best practices for dealing with various types of feedstocks in the Irish context and in other European countries as well. And within that project, we also have a database of composition of Irish feedstocks, their arisings, and potentially the yields that you could get from processing these in different types of technologies. And there's a number of articles here that we have written that you can, we'll be happy to provide to you if you'd like to read more about the chemistry, about the Irish potential in various types of contexts of using biomass. So that's it from me. I'm very happy to present to you today. I'm very happy to answer any questions that you have now going forward. So thank you for the opportunity to talk.
That's great, Dan. Thanks a million for that very interesting and informative presentation. And look at half the stuff that you had included, I wasn't aware you did, so it's great to see, and some really interesting sort of different packages that you offer and different projects that you're involved in, not just here but abroad. I might just ask my colleague Noel Gavigan to maybe switch on his camera and to join us for the panel discussion. And if you have any questions that you want Dan to address, would you just pop them into the Q&A tab there? Dan, you can leave your camera on as well, and we might come back to you now in a moment. So Noel, if you don't mind, I might just start with you, and I suppose maybe just from your own experience between the last number of years working with Erbia and the various different feedstocks you've come across, maybe you could just maybe outline the importance of having such facilities and testing capabilities within an Irish context, and what it means for the bioenergy sector in Ireland. Yeah, so what are your impressions of it?
It's a vital service. I mean, we are in a very exciting times in the whole bioenergy, or as the bioeconomy space. Bioenergy is only part of it. And being able to properly measure, monitor, and research various different ideas as the years go on is critical. And we have to have accurate measurement. We have to have repeatable measurement systems that we can stand over. So I think the service that's provided is absolutely critical for us to be able to develop properly. Over the next number of years, we're likely to see all sorts of ideas come forward, all sorts of products. I mean, the petrochemical industry has had 100 years head start on all this. And I think from a bioenergy, or sorry, I keep saying bioenergy, but from a bioeconomy point of view, we have quite a lot of catching up to do. There's quite a lot we can learn from what's been done already. But we need these facilities. We need, and the expertise is not the facility, it's the expertise. And it's great to see the expertise is growing. The line of staff there that Daniel has is excellent. So I think that's just vital, to have it there. And I suppose the question is, I'd put to Daniel on it, is there enough being done to support that? Do we need to see more investment in this area? What's the critical areas? I don't want to interrupt other people's questions coming in there, but for me, I suppose I'd ask, what are the key things we need to push forward on now? What sectors do we have to really consider here? Is it support for pharmaceuticals and the food sectors? What can we do from our side to push things forward?
So in Ireland in recent years, I think it's improved quite a lot. There has been, it's taken time, for example, for the anaerobic digestion sector to grow in this country, whereas for previous decades it's been operational much more extensively in places such as Germany. I think there's finally an increasing understanding of all the positive externalities you can have from AD beyond just the energy generation, in terms of dealing with waste, in terms of rural economy improvement, in terms of employment and so forth. But I don't think we're quite there yet. I think in a policy context, in a governmental context, they're still always focusing on the cheapest cost of energy production. And unless you consider all of these other externalities, you're never going to have anaerobic digestion win there. However, if you do include those in, it really is a convincing technology for addressing our energy needs going forward. There's no one process, but I think AD in particular is something where we have existing technologies, there's existing feedstock, there's a huge potential in Ireland, and there's promising signs going forward, but I think whenever government officials look at this, they need to go beyond the simple numbers of cheapest outputs per gigawatt, per megajoule cycle. They need to consider everything going forward. And if they do, we can see this sector improve greatly.
Yep, that's great. We have a number of questions coming in, so we might just address a few of those. So the first one here, in your review, what Irish biomass feedstocks are most economically viable for electrical energy production?
Well, again, this goes back to the first slide I have, really. So a feedstock is economically viable in the first instance if it's cheap. However, you have the issue that the cheapest feedstocks tend to be the most awful, generally, in terms of their composition. So if you're dealing with a waste material, you can, for example, typically have a lot higher ash content in those, a higher chlorine content. You have all those issues related to the degradation and the slagging of the ash that you're talking about, that I referred to earlier. So it needs to be looked at within the context of the capabilities of the boiler system or the power plants that you're looking at. So in the current context, if you're talking about electricity production from the combustion of biomass, you need to have feedstocks where you have low amounts of chlorine, you have low amounts of ash, and you don't run into these ash slagging issues. And that restricts you to some degree. So you're looking, in that case, predominantly at woody materials. And there are some opportunities now going forward related to production of coppices, for example. So willows and poplars, these can be grown at relatively low cost in high productivity, and they have compositions and thermal profiles that are suitable for combustion in a variety of boilers and existing power plant stations. If you're talking about anaerobic digestion, of course, you can produce electrical energy that way as well. Then you have a whole other set of considerations going forward related to how well that feedstock will degrade under the AD conditions. There is a huge potential in Ireland, again, nationally for AD, as I mentioned previously. Grass is good going forward. You have lots of slurries and so forth from the agricultural sector. In that case, again, it's about how you balance these. So you're not going to go for monoculture, you're going to go for a mixture of different feedstocks. And it's about how you effectively balance those together in order to get a plant that operates efficiently over time.
And I guess that underpins the need for accurate data and testing of your feedstocks. So,
thanks for mentioning that, Stephen.
Yeah, of course. Now, next question we have here: what are the typical sample numbers associated with your near predictive equations, your near infrared?
So it can work in two ways. So we have global models where we have everything in there. We have about 10,000 samples of biomass, and everything you can imagine is in there. You have wood, you have grass, you have straws, you have manures, and all these kind of things. And then that global model can be used to predict the composition of an unknown sample, let's say a wood, for example. This is what we currently use. And it works pretty well considering it is such a broad data set. What we do in a different context, we do on a case-by-case basis for clients if they're looking for repeat analysis over time, is we develop dedicated models focused on a particular feedstock. So for example, we've done this for miscanthus, we've done this for various types of woody materials, we've done it for processed residues from a number of different biorefineries across the world. In that case, because your models are only dedicated on one particular type of material, you can be much more accurate for the sample that you are looking to predict. The numbers that are required, it's not purely based on numbers, it's about getting a representative data set that covers all the expected variability that you would expect to see for that type of material. So we would say we can start off with about 30 samples covering that range, and we can see, look at developing a dedicated model based on that type of number of samples and use that going forward to predict the composition of unknown samples. So it starts off with 30, but it depends on the particular conditions that you're looking at the time.
Perfect. Now, next question we have here from Norman. in the context of biogas from AD, where can data be found about the percentage destruction of volatile solids for a feedstock? Or where can biodegradability data be found for feedstocks in an open source, and whether this can be calculated or estimated? So I'm not too sure if you have an answer for that.
Well, we provide it in our reports, but you're looking for an open source thing. I think we have something available. It's Norman. I can get back to you, Norman, with some.
Perfect, Norman. If you get in touch with us, we'll connect you afterwards. And another question from Norman here: why would one not routinely operate AD for long hydraulic retention times? So 100 days versus 35 days. Can it just be digester size and cost, given a digester operates for over 20 years? So,
oh yeah, and it's you have a significant capital outlay when you're building these facilities, and you need to get the return as quickly as possible. And it's challenging even now under the best circumstances for anaerobic digestion. So you want to make as best use you can of the facilities that you have. So yeah, a particularly important part of optimizing an AD process is to reduce that hydraulic retention time. And within the project that I referred to earlier, the STEAM project that was funded by the IRC, we have a PhD student here at Celignis, but working with Jerry Murphy from UCC. What we're doing is we're developing low-cost approaches focused on biomass, locally available Irish farm biomass feedstocks, where we can do a sort of a cheap pre-treatment, which will allow us to reduce the hydraulic retention time and improve the biogas output from these facilities. And it makes the whole thing more economically viable. And ultimately, the target is that it will be viable at a farm scale, which is something we haven't seen, although it is something that I must say Obeya is working on at the moment with their national projects. So it's good to see that.
That's excellent, and that kind of addresses Tomas's question here about the STEAM research project and what it was focused on. So you've answered that question before it was asked. And then I have a question here from Tom. Could Daniel tell us a little bit more about the substrates they're looking at in Africa and in which countries, and what value chains are they looking at?
Okay, so there's two projects that we're involved in. One of those is called Bio for Africa. A fellow partner is MTU, James Gaffey, as a lot of you probably know. In that context, we've recently analyzed about 50 different samples of African feedstocks from 4 countries. So there's Ivory Coast, Senegal, Ghana, and Kenya, and all kinds of different materials that you can imagine. So there are 2 types of technologies that the project is focusing on. One is the green biorefinery that has been demonstrated in Ireland under the James Gaffey's project. Name I forget right now, but it's something like green biorefinery. So in that case, they're looking at production of nutritional value side streams from the extractives and from the sort of herbaceous types of materials. So we've been looking at various types of grasses, various types of agricultural residues suitable for that process. The other technologies then are looking at biochar production and looking at hydrothermal carbonization. And in those cases, then it's a different type of material that you're looking at. So we're looking at ones with a higher carbon content, lower moisture contents. So in that case, it would be things such as shells, husks, straws, and so forth. As part of the project, there will be shortly published a database of the data that we have obtained in analyzing these feedstocks. So anyone who's interested can log on to the Bio for Africa website and see the compositional data that we achieved. The other project is called STEAM Bio Africa, and that is focused on one specific feedstock. So it's a bush plant that is a weed across millions of hectares of southern Africa, and it's within that project they're looking at a torrefaction technology. So steam-based torrefaction, where they are basically producing an improved biofuel product for combustion. So they are, by the process of torrefaction, they are removing the hemicellulose component, which comes out in the steam condensate, and we are doing work within the project characterizing that and looking at that as a substrate for the extraction of high-value chemicals. But the main product is this torrefied material, which is a much cleaner burning fuel that they can use more sustainably for the energy needs of the local community.
Excellent. And I suppose you, just in your presentation, you referred to the seaweed analysis. So there's obviously a very much a growing interest in sort of the different streams that we can take out of our seaweed resources. Do you see much interest, aside from sort of the valuable compounds, do you see much of that research going towards the generation of bioenergy, or is it mostly for the likes of nutraceuticals and different? Or can you see
the
potential?
Bioenergy, it can be challenging for seaweed. For example, you're talking anaerobic digestion. There's issues related to the sulfur content of seaweed. There's issues in general related to logistical operations of seaweed. So in terms of harvesting, collection, processing, and so forth, it makes everything more viable if you can have a product that is of higher value. So bioenergy can be difficult in terms of that you're competing with other forms of energy which are relatively low cost. Whereas if you look at the chemistry of the material that you're processing, it's better to work with that chemistry than to work against it. So if you have high value constituents in there, ideally you can develop a technology for valorizing those, getting higher value products. And then what you're left with might be ultimately itself a more sustainable residue for energy production. So it's about this whole cascading use of biomass principle. And we see seaweed is particularly relevant in that context for seaweed in the Irish context as well.
Right.
To come in there for a second, Stephen. Daniel, where do we see the products or the materials most close to economic validation at this point of time? There's obviously a lot of research going on at trying to identify all the materials we can extract and utilize. But are we far off commercial stage in any of these things, or what's the road ahead looking like?
No, things are happening now, and you have companies producing bio-based products and actually getting significant revenues from it. So there's numerous examples. One would be Avantium, for example. They're producing Coke bottles now via a biological approach. And the particularly exciting thing going forward about using biomass to produce bio-based products is that we can ultimately get products of better quality that we had from the fossil fuel route. So in the case of these bottles that they're making, the oxygen diffusion is less than from the fossil fuel. So that, for example, they're able to produce beer bottles that are plastic now, bio-based plastic, whereas previously they couldn't do it from the fossil resources. And there's a lot of work going on with lignin is another notable example. So Maurice Collins, who a lot of you might know at the University of Limerick, has been involved extensively in lignin research, and he's been leading a number of research projects, and these have been developing commercially relevant technologies for producing carbon nanofibers and other types of products from the lignin that again have superior or competitive qualities with the current alternatives that we have in the market. So it's no longer a theoretical thing, there's actually things happening out there now. Nanocellulose would be another one, and of course the work that we're doing with Xylan and hemicellulose, we believe it's going to be particularly exciting in the production of bio-based polymers in the consumer market. Okay, well, I think we're approaching time there. I suppose I'll just come to you, Noel, for final comments. Any final comments you want to finish up with, and then I'll come to you, Daniel, and then we'll wrap it up.
I think it's very complimentary developing these high-end products, and they are on the very high end of the scale. I mean, it really changes the dynamic of what we're producing from our biomass material. So I think the more we can encourage this from a policy perspective, the better. I mean, the fact that this product's on the ground, it really is groundbreaking in terms of it's probably an area that Ireland can develop and can be seen as a world leader in. So it's something that definitely should garner much greater support. So I think the only comments I would make on it is it's a space we should all be watching and working on more. And look, bioenergy is always the catch-all at the end of all these things. There's always going to be a material at the end that can't be used. But if we can have our raw material extract the highest value products out of it, it's cascading in its best form. And in the end, we'll be left with energy products. But ultimately, it's to take the raw material we have and maximize the value we can create from it.
That's perfect, Noel. And then over to you, Dan, for a final comment, and we'll wrap it up then.
So yeah, I echo everything that Noel's just said. We are very excited about the potential for biomass in Ireland. We see there's huge availability of biomass materials in this country, in which we could really be self-sustainable in terms of bio-based products, in terms of energy, in terms of fuels. It's all about doing it right, doing it intelligently, looking at the best routes for using the biomass, the best technologies. And I think we have a great team of people within this country actually going forward to make this work. So we're very excited to be here and to work with them in the future.
That's brilliant. Thanks very much. Rightio, with that, we'll wrap up this session. We'll be back in 2 weeks' time, and keep an eye out for the full details. I'd like to thank Daniel for presenting and for a very interesting and informative discussion, and thanks to Noel for participating in the panel discussion. And as always, a big thank you to Teresa O'Brien, who's behind the scenes and makes sure everything works seamlessly. So with that, wish you all the best and take care. We'll talk to you soon.
Thank you.
Thank you.